Welcome to the Manitoba Ag Days podcast, featuring speakers from our 2017 event. This podcast features Drew Lerner from World Weather Inc., and his talk is called, Will the Weather Extremes Persist on the Prairies?
All right, everybody's so far away, Hey, makes me look smaller, right? He's now 3 inches tall. Great, thank you. I need to figure out where everybody's from today. So how about a show of hands from anybody here from Alberta? I can't even see anybody's hand, so I guess no one's here, right? Oh, okay, there's a couple over there. The light's just kind of blaring there. What about Saskatchewan? Yeah, okay, all right, and of course Manitoba, right? That's the rest of you. Okay, all right, well, I'm glad I'm down this far away from you because those of you who are from Manitoba probably don't want to deal with me too much right now. The snow that's on the ground is a real worry, and I know you guys are worried about it, and probably need to be worried about it a little bit. But I think as we go forward through this morning, we're going to be able to put some of that ease to rest because of the fact that I think we're going to be a little bit warmer biased for the next few weeks, and that will help to whittle down some of that snow. And perhaps we will get to the spring thaw and won't have quite as much snow to melt. Now, that doesn't mean a whole lot, because if we get more snow, it's a whole other story, right? And so that's what the big concern is. Manitoba and North Dakota are the only two places in agricultural country in North America that have a real problem with excessive snow on the ground, unfortunately. What I'm going to do for the next 45 minutes is kind of entertain you, of course, do a little soft shoe dance, try to pretend like I know what I'm doing, and try to leave you with some kind of impression of what the growing season is going to be like. So what I want to do is start off with a little drought monitor type thing here and show you where all the drought is, right? And most of you know there is none, right? The white on this chart is basically no area is abnormally dry. The only area is in the southeastern corner of Ontario, actually southeast corner of Canada in general, in Ontario's corn and soybean production areas, as well as in some neighboring areas there. Is the only drought that's in crop country across Canada right now. There's some dryness that's in southern Alberta, but it's not really significant enough for us to be concerned with it festering into another dry start like last year. A quick glimpse at last year. I don't need to explain too much to you. You know it was wet. It's been wet for a number of years. We've got a problem on our hands. Most of you guys are here because you want to find out if it's ever going to stop raining. And the answer to that question is sure, but when, right? All the blue color that's on this chart is in the top 10th percentile of the wettest years in recorded history from Environment Canada. So that basically means that the entire Prairies was within the 10 of the top dry or wettest years. I probably said dry, and that's not right. The purple up there is actual record setting for the growing season last year. So from April through October, anything that's purple up there on that chart was record setting rainfall. And that's a pretty big part of the production area, as you know. The situation has been ongoing for a while, but this is kind of interesting. In recent weeks, we've gotten away from some of the surpluses. This is a 60-day precipitation chart that you're looking at. Everything that's up there that's orange or brown, we're talking about moisture totals here. They're not much more than 20 millimeters for 60 days, and quite a bit of that region is even less than that, around 10 or 13 millimeters. That is great for all those folks out there who did not get your crops in, who you've been worried about whether you're going to get those crops in. The good news is so far we don't have that much moisture out there, and the snow cover is thin with the exception of here in Manitoba, and the potential is really quite good that we will get a chance to get into the fields and get what's left of last year's crop out and have still time left to put the new crop in. So it's a pretty good situation, I think, relatively speaking. The percentage of normal precipitation in that same 60-day period is what you're looking at now. Anything that's up there that's red is less than 40% of normal precipitation in the last 60 days. The areas that are orange colored would be 40 to 60% of normal, and you get into the yellows and you've got 60% of normal, 60 to 80%. So a big part of the prairies has really come along not so moist, and that's great. Snow depths out there are not all that impressive. And if we were to rank all of the precipitation that has occurred since the 1st of November against all of the other years that Environment Canada has kept data, we would find ourselves ranked again in the top 10th percentile of the driest winter season so far. The little red dot that you see there in parts of Saskatchewan near the Alberta border would actually be a record dry season so far. That's since November 1st. That doesn't really tell us much, right? Because we have a lot of moisture in the ground and some snow to melt as well. But it's still one thing that's probably worth noting for those of you in Manitoba is the southeast corner of this chart, which you see the blue, and that is puts you in the top 10th percentile of the wettest of the winter season so far. And almost all of that, as you know, was concentrated in December. And a pretty interesting phenomenon that was. The reason why that happened is the storm track in the U.S. was such that storms were coming one right after the other across the Central Plains and into the upper Midwest and Western Great Lakes region. And each of the low-pressure systems were just the right size so that all of the wraparound precipitation was coming back through Manitoba and resulted in those blizzards and all of the significant snow accumulation. Since then, the jet stream has moved down into the U.S. more deeply. The same basic pattern is still existing, but the jet stream is just far enough to the south now that we aren't seeing all of that moisture any longer. This last chart is just 14-day precipitation, the last 2 weeks, and you can see that almost everything up there is a rather orangish, rather red-brown, I guess would be the color you'd call it, and less than 4 millimeters has occurred in quite a few areas. If we can just keep this pattern going for the next several weeks, it would be a really good thing for almost everybody in this room, I'm sure. And I think there is potential that we will do fairly well in minimizing the precipitation, but not necessarily going completely dry. It won't be like last year where it was just dry and warm. We obviously have had shots of cold air. That's gone right now. It will come back, but not nearly as cold as it was. The snow cover chart reveals a lot. Unfortunately, I have to show you it from a U.S. perspective because getting a snow water equivalency chart out of Environment Canada this time of the year is really hard. And so I want you to concentrate on the top part of this bottom chart. The top chart is actual snow depths, and I'm sure it's hard for you to get a feel for what they are, but you know that right here in southern Manitoba is where the greatest snow is, and we got 20 to 30 inches of snow on the ground. But I want you to look at this bottom chart and look at the colors here. The pink color is what I'm most interested in. That's water equivalency in the snow that's on the ground. And when you get into that pink color, especially the bright pink, you're talking about 2 to 6 inches of water tied up into the snow. And there lies the big concern that a lot of you have from Manitoba here, because if we were to melt all of that at once, we would have a real serious flood in the Red River Basin area because the ground is saturated beneath that. And so the whole idea here is that we're going to try to whittle down that moisture surplus as we move forward through these next few weeks. So important that we get as warm as we can be over these next few weeks so that we can melt that snow gradually. We don't want to get into late March and early April and bring in, 20 plus degree temperatures and all of a sudden we melt all that snow in one quick flash and then we've got a real serious flood problem on our hands. So warm weather for the next few weeks is really a high priority. This is soil moisture chart that we have right now. Keep in mind that the soil is covered with snow and it's frozen to a certain degree. So this is more or less a reflection on where we left things last October. And all the green up here would be adequate moisture. The top chart is the topsoil. The bottom chart is subsoil moisture. Topsoil goes down 18 inches, subsoil down another 18 inches, so you're 36 inches down. The light yellow that you see in southern Alberta is a bit of the short, not quite very short, but there's some short moisture there. And that's probably good for them. In fact, it suggests that as we get closer to the spring planting season, there won't be a big surplus of moisture there and fieldwork will go along fairly quickly. On the other hand, you get into the southeast corner of Manitoba, and this pointer doesn't work too good, but you know where it is. the ground is really quite wet, as you know. The further east you go in Manitoba, the more serious the moisture surplus is, and the higher the potential is that the flooding would be a significant event if we melt that snow all at once. Here's a close-up shot of the snow cover at the top and snow water equivalency at the bottom. And again, I'm sorry it's biased for the U.S., but you can certainly see the snow that is greatest depth occurs from North Dakota into southern Manitoba, and all this pink area that extends across most of southern Manitoba and down into a big part of North Dakota would be what I would consider to be the flood risk area. That's the area where the potential for the greatest amount of runoff is highest and where the potential for serious runoff into the Red River Basin area would occur and where our problems could be. The worst case scenario, of course, is that we go back into a wet weather mode. You maybe even get frequent snows or even some rain in the spring, and all this becomes a very big problem. So we need to do a lot of praying, and I think that's certainly what we're probably going to have to do. All right, so that kind of sets the tone for things. The bottom line, Manitoba has the biggest potential problem with too much moisture. The rest of the prairies are really in fairly good shape. Now, I know northern Alberta, too wet, right? But there's not as much snow up there as there could be. So that's a good thing. Southern Alberta has the least amount of snow on the ground, the driest soil. If we were to go into spring today, that would be the best place for planting. The heart of Saskatchewan, quite a bit of variation. There's still some problems with excess moisture. Anyone in here from Hudson Bay area? Yeah, well, it's really, really wet up that way. They are going to have some issues in the spring for sure, but the majority of the province is doing fairly well. What you're looking at here is that infamous chart. If you've heard me speak before, it's all about the ocean surface temperatures out in the eastern Pacific Ocean. And we're most interested in this region because this is where El Niño and La Niña live. Today, we have a weak La Niña still hanging on. To a certain degree, La Niña was at least somewhat instrumental in creating the wet bias that we had in the summer last year. We never had an official La Niña. But it was close enough that we were getting feedback from the atmosphere that was supporting a lot of the wet bias. Now, that's in addition to the fact that we were in this wet weather pattern, just like the 1950s, so La Niña capitalized on the already present wet bias and kind of perpetuated the situation. So we want to find out now what's going to happen to this La Niña-like environment, and that's why I'm showing you this chart. You're looking at a cross-sectional picture of the Pacific Ocean. The horizontal black line going across the chart from left to right is the equator, and the vertical line, if I can get it to, is this line right here, is the international date line. We're interested in the body of water that is between the international date line and the coast of South America, which you can see way off on the far right-hand side. You can see Mexico, Central America, and South America there. So we're interested in that equatorial region of the Pacific Ocean, this region right here, plus or minus 20 degrees of latitude of the equator. That's where El Niño and La Niña live. Now, the blue color that you see along the equator in that region is cooler than normal ocean temperatures. In order for a La Niña to exist, that water there, within 20 degrees of latitude of the equator, needs to be colder than normal. And not just slightly colder than normal, but significantly colder than normal. And we are, at this point in time, teetering on just barely a La Niña, okay? And that's the way it's been. We really need to see these darker blue colors occurring all over this basin area and extending further north and south in order to have a real true La Niña on our hands. If that water was warmer than normal, it would be an El Niño. And I know a lot of you have heard me speak before, and I've kind of explained why this is important. And I'm just going to take a minute just to go back over that again for those who have not heard that before, just so you understand why El Niño and La Niña are so important to us here in Canada and the rest of the world. If you were to take a pot of water and put it on your stove and not turn the heat on it, put your hand over the top of that pot of water, the bottom of your hand wouldn't feel any different than the top of your hand, right? You turn the heat up on that pot of water and stick your hand back over the top of it again, and the bottom of your hand gets all warm and sweaty. The reason why that happens is you're exciting the water molecules in the water. As it gets warmer, they get excited, they eventually jump out of the pot of water to get away from the heat. But they do so as minute water droplets. And in your kitchen, you call that steam. In the world of weather, we call that water vapor. And it happens in any body of water, anywhere, anytime you raise the temperature of that body of water. So you raise the water temperature, you increase the amount of water vapor that is suspended above the water itself. As you heat up that water and the water droplets get into the air around the water droplets becomes warmer too. And as that air warms, the whole conglomeration, what do you want to call it, starts to rise. Just like if you were to get into a hot air balloon, you know, you put a fire in the middle of that hot air balloon, the air inside that balloon becomes less dense. And as it becomes less dense, the air outside the balloon comes rushing into the opening and pushes the balloon upward. Okay? The same thing happens with that pot of water. The air above that pot of water becomes warmer, just like putting the fire in the hot air balloon, and the air starts moving upward. And as it goes up, it takes the water vapor with it. Okay? That water vapor goes up and turns cooler. Eventually it rains because of the condensation. But the point is, if I stood on top of that pot of water and the air was rising, there would be less weight of air on my head, right? Because the air is moving upward. That's called a low pressure center. Okay? So your kitchen, when you put a pot of water on the stove and you turn on the heat, you create a low pressure center. Any area of water out in the Pacific Ocean that becomes notably warmer than normal can support a low pressure system. And the thing is, when we have an El Niño, when this water body becomes very warm, you create a massive sized low pressure center that basically covers almost all of the east half of the Pacific Ocean. You create a low pressure system that large, and the rest of the world weather has to change accordingly because we live in an equilibrium. So if you get a big low pressure system in the middle of the Pacific, you got to get a big high pressure system somewhere off to the right and to the left of that low pressure center. So in an El Niño event, you create a chain reaction of shifting high and low pressure systems around, and they're not little systems, they're great big systems, and because of that, you change the weather in the whole world. Okay? And because El Niño and La Niña always live in the same area of the Pacific, the response in the atmosphere is basically the same. The same high pressure systems occur in this part of the world as in that part of the world, and so meteorologists think they can forecast the weather because of El Niño and La Niña, okay? The truth of the matter is we can't, because that's not the only game in town. There are other weather patterns that prevail, but this La Niña and El Niño thing are the biggest things that can influence our atmosphere in a major way. So we don't have warm water there. We have cold water there, okay? And the cold water means that the warmer water is somewhere else. And in this case, the warm water is in the western Pacific, and also, you can't see it, but off the north coast of South America. 2 areas of warmer than normal water. So we have low pressure systems in those 2 places, and over this colder water, we have a high pressure system. So the bottom line is that La Niña, which is what we have weekly, is just the opposite of El Niño. So if you know what happens in El Niños, then the opposite would occur in La Niña. Here in Canada, if we have an El Niño, our summers tend to be a little drier and a bit warmer. Okay? You get a La Niña going, and we tend to be a little wetter, especially the further west you go, and there's a tendency for the temperatures to be a little bit milder because of the moisture. So last year's La Niña helped to generate all that moisture in Alberta and parts of Saskatchewan. Okay? Today, I want you to know that this body of cool water is very weak, and it is going to continue being very weak. In fact, it'll probably go away. One last chart to confuse you, and then I'll get into something you really want to know. These are cross-sectional pictures of the ocean as well, but each one of the boxes represents the water itself. The top of each box is the surface of the ocean. The bottom of each box is 300 meters below the surface of the ocean. And the blue color is colder than normal water, and the yellow and orange and red are warmer than normal. Now, in the Pacific Ocean, and by the way, this vertical line is still the international date line, just for reference. I've taken the continents off because we're looking under the water now. And what I want you to note, take a look at that circle I've drawn on that map and put your eye in there. The top left map there is from early December, I believe. I'm not even sure at this point. I think it's actually the November 19th. The chart underneath it is December 4th. The third one down is December 16th. The bottom one on the right-hand side is January 3rd, and the most recent is January 8th. Now, take your eye into that circle. Look what's happening in that circle as you scan down. A lot of cold water inside that circle when we first start in November. As time goes on, the cold water disappears, And that's what we need to pay most attention to. Okay? The trend is not for making it more cold. Okay? The trend is for warming that water. Therefore, La Nina probably won't last very long because there's two ocean currents that prevail out there. One is a west to east movement, represented by this arrow. The other one is a bottom to the top of the ocean movement. We call that upwelling. So as you move water from the western Pacific into the eastern Pacific, once it gets far enough to the east, it gets pushed to the surface of the ocean by that upwelling current. So if we have colder than normal water that's in the eastern Pacific, it gets pushed to the surface. As that colder water disappears, you don't push any more cold to the surface, and La Nina goes away. So my point here is that we're losing the cold water in the eastern Pacific. At the same time, we're building up warm water out to the west, and that's going to be moving further to the east. Now, you may be ahead of me and thinking, well, does that mean we're going to have an El Nino? And the answer to that is no, because there's not enough warm water there, and knowing the ocean as I do, it'll take a much longer time to build up enough warmth to really create an El Nino. The bottom line to all this yakety-yak is that there is not going to be a La Nina in our growing season this summer, at least not for the next 3 or 4 months. Now, to be real honest with you, we don't have a clue what changes the ocean temperatures, and we can only go out about 3 months and be able to tell you something and guarantee it. Once you get beyond that time point, it's a big guess. So we just a little caution there. I'm going to tell you there's not going to be a La Nina this summer, but we may get to April or May, and things have changed, and I may change my mind as well. This is a forecast of the El Nino La Nina thing from NOAA. And all you really need to know is that each one of these hairline plots is a forecast. The heavy dash line is the average and the official forecast. Everything that's above the red line here will be warmer than normal ocean temperatures. Everything below the purple line would be colder than normal. You can see that over the past year, a year ago, we were coming out of El Nino, and we went into a very weak La Nina to the south of that purple line, right? So we never really got into a big, bad La Nina. And now we're headed back into what we call neutral ENSO conditions. And over the next several months, we will have no influence from this particular phenomenon. I heard a rumor in the marketplace last week, and somebody's out there already saying we're going to have an El Nino-like environment during 2017. And I'm telling you right now that that is probably false, and don't buy into it. I don't think that'll happen. But that's just me against the rest of the world. So the other thing we have to look at then, since we don't have El Nino and La Nina, is the 18-year cycle. And if you've heard me speak or seen my writing, you know that this is my baby. This is what really tells me everything I need to know about where the weather's coming from and where it's going, and it gives me a really good idea as to what's going to happen in the seasons ahead. Usually. All right, on the left-hand side here, I've got 3 different maps. These are upper air wind flow maps that illustrate the jet stream at 18,000 feet. All you really need to know is the upper air winds will follow the lines. So they'll come from a general west-to-east motion. So if you're let's do this middle chart. If you're somewhere off the Oregon coast, the air aloft is going to flow from southwest to northeast. It's going to get over to the interior part of the northwestern U.S., and then it's going to suddenly turn from northwest to southeast. Okay? That's all that this chart really tells you. If you scan through those 3 charts, you can see that there's a certain amount of similarity in those charts. This is why it's called the 18-year cycle, because each one has a little bit of a ridge on the west coast and a trough in the eastern part of North America. Now, the reason why I say this may and may not help us out with the forecast is because these charts do not agree as well as they should. Okay? To you, it may look like there's enough similarity there that I can tell you what the forecast is going to be. And to a certain degree, that's true, but relative to what it usually is, that's not the case. Because if you look at the top chart, there's not nearly as much amplitude in the ridge as there is in the middle chart. And even on the bottom chart, there's more ridge, but it's further out to the west. What this suggests is that the flow pattern across North America is not consistent going back at these 18-year cycles. Normally, each time we go back at 18-year intervals, we would see a very similar pattern. And when it's a strong signal, when you hear me talk with confidence, it's because this 18-year cycle business is presenting the same pattern each one of the 18-year cycles that are out there. Now, this isn't terribly off, but it's not as strong a signal as I want and I need because we don't have El Nino and La Nina. And having a weaker signal in the 18-year cycle introduces the potential for error and also introduces the potential for other smaller weather patterns to stick their nose into our business. and we could end up with some kind of anomalous weather pattern because of some weird short-term phenomenon that occurs. So caution is going to be necessary as we finalize today's official forecast, because until we get the 18-year cycle back aligned, which it will do in the spring, we will have a little bit of weakness in the official forecast. So that's really important to keep in mind. Here is what I'm talking about. This is our 18-year cycle chart, at least through the first part of January. If you compare that chart on the right-hand side with the 3 on the left, you can see that there is not a lot of agreement there. There is not nearly as much ridginess on the western part of North America. The trough in the east is not nearly as sharp. We've had a lot of variation in North America weather in the past several weeks, so this creates the problem for me. The bottom line, though, is that we will get back to this, and the question is, why are we off base here? The answer is the La Niña. Okay, the La Niña event, because it's weak and because it's kind of going away right now, the atmosphere is becoming a little bit more confused. And as it becomes confused, the flow pattern becomes mixed. And like I said, other little short-term weather patterns will stick their nose in and kind of shake things up a little bit. And that's what's happening. Until La Niña completely eliminates itself from the flow pattern, we're going to have this noise in the system. So for the next few weeks, I'm going to give you a forecast, and I feel pretty strong about it, but there's a potential, as long as La Niña is still kind of hanging around in the background, that it might just waver a little bit. And that's too bad, because I really feel comfortable with telling you guys that it's not going to be all that terrible here as we go into spring season. But we have to kind of keep our fingers crossed and maybe go to church on Sundays once in a while, just in case. This is the best chart I can show you right now. These are 4 single-week forecast temperatures coming from one of our many forecast models we have. And this is the most exciting. These are all temperature forecasts. And for those guys way up in the top and you can't read what's up there, all you really need to know is that everything that's yellow, orange, or red, or even purple, is warmer than normal temperatures. This first chart here in the upper left-hand corner is for the week ending January 24th. We're in the midst of that right now. The entire continent, except for the western part of the U.S., is going to be not only warmer than normal, but much warmer than normal. That's a no-brainer, right? Temperatures outside is, -2, -1. It's really, really good weather. But the second chart, which is the one underneath it, the lower left-hand side, is for the 7 days ending January 31. And you'll notice again, the prairies, as well as the eastern part of North America, is still engulfed in unusually warm conditions. All of this area. And so that gives us another week of this opportunity here, with afternoon temperatures getting a little bit above freezing, melting a little bit of snow, just a little bit at a time, freezing up every night, but helping to whittle down the situation here in Manitoba in particular, and other areas across parts of Saskatchewan and Alberta that are all also dealing with some significant moisture issues. We get into the third week. This is the week ending February 7th, which is in the upper right-hand side of the screen. Again, Canada is still in the warmth. This is pretty good. We want to keep this going as long as we can. Colder bias in the western part of the U.S. and the southeastern U.S., but still most of the prairies and even eastern Canada continue to be warmer biased. And look at the week that ends February 14th, still warmer than normal. If we can go all the way to February 14th and keep our temperatures slightly warmer biased, keep the jet stream in the southern parts of North America so the U.S. gets all the storms, we could easily whittle down a lot of this snow depth that we have out there and reduce some of the potential fear that we're going to be belly up over the spring season. So I am very encouraged by this. Now, this model that you're looking at, it's a little questionable sometimes when you start getting out into week 3 and 4, okay? Just being honest with you, we don't know what we're doing, right? And so we got to be real careful. But this model has performed well this year. And I do think that looking at the 18-year cycle, it matches fairly well. And so I am encouraged that this is where we'll go. What about precipitation? Anything that is green on this chart would be wetter than normal. The yellows would be below normal precipitation, and white would be near normal. And you'll notice that most of the Canadian prairies on all these weeks stay in a fairly normal realm. Now, normal precipitation across the prairies is not that much. And if we can keep the temperatures a little warm, we could probably manage to keep our snow depths to a minimum. And that's what we really want to do. It would be better if it was below average, absolutely. But it's not going to be. We aren't going to be absolutely dry. But we'll be at least not seeing big blizzards like we saw here in December. And the odds are fairly good that it will be warm enough that maybe we can keep a little bit of the snow melting once in a while. So this chart is pretty encouraging too. It's not the best scenario, and I don't want to gloss over it and just kind of say, well, you know, everything's going to be fine, just go home and relax. Because that's not necessarily the case. I still think Sunday school and church on Sundays is really a good idea. Okay, here's the official forecast based on all this yakety-yak, okay? For the next, through February 14th, the top chart here is the temperature forecast, the bottom is precipitation. The top chart temperatures, yellows are warmer than normal. Yellow hatching with green is near to above normal temperatures, and the green is near normal. So the further west you go in the prairies, the more normal the temperatures will be on average through February 14th. And the further east you go, the warmer the bias will be. Okay, and you saw the forecast for the next 2 weeks. It's a given that this is going to verify. Because even if our temperatures go back to near normal on weeks 3 and 4, we're going to be so far above normal here this week and next week that it'll average out so that it's warmer than normal. So please write that down. Drew is going to be right, okay? The bottom chart is the rainfall or precipitation, snow and rain. Anything that's green on that chart is near normal. Anything that's hatched with brown is near to below average precipitation. Now, you can't see this very well in the back, I'm sure, but all of Manitoba and the southeast part of Saskatchewan is near to below normal precipitation. The only wetter bias near to above average precipitation is along the front range in Alberta. So southwestern crop areas would have a tendency to be wetter biased. That's for the next 30 days. Okay, let's get closer to the growing season. For the next 30 days, February 15th to March 31, it's actually 45 days in case you were trying to catch me. The temperature bias is going to be cooler again in the eastern part of the prairies in that latter part of winter. The last few weeks will be a little cooler biased, and if you look at the chart at the bottom, the blue and green hatching there is for near to below average precipitation. So the latter part of the winter season will be a little bit drier bias still, but it's going to be cooler. So we're going to lock in a lot of that moisture that's still there. So whatever we can whittle down the next few weeks will be probably where we'll end up when we get into late March. Okay, so real quickly, let's look at this 18-year cycle for the spring and summer. Okay, what I want you to notice, first of all, in the spring, which is the left side here, there is still some variation, unfortunately, in the 18-year cycle charts. They are not in good agreement. They're in better agreement than the winter season. That's good. But I like a couple of things here. The areas where they agree most is right here in Canada. They all have a little bit of ridginess across Canada on the left-hand side. If you see that, that's a good thing. That means we might just have a little bit of a warmer bias as we go into the spring season. And that means what snow we have, we might be able to get out of our way fairly quickly. And for those of you who still have crops out there in the fields, an opportunity will manifest itself into your life and giving you an opportunity for getting into the fields early enough to get the old crop out and still have enough good weather to get the new one in. Now, just because there's a weak ridge over there and it's warmer bias doesn't mean we're not going to see any precipitation, okay? It will precipitate. It's just not going to be real wet, but it's going to be a little, tenuous. Let's put it that way. Now, the summer charts on the right-hand side are in much better agreement. There's a lot of consistency. They all have the same ridge in the middle of North America. It is a weak ridge of high pressure. If it verifies exactly as it is, what would happen is that we would have a mix of weather. It's going to rain again this summer. It's not going to be dry. This ridge is too weak. We need a stronger ridge, one that goes from the central U.S. all the way up to the Arctic Circle, and it's got to be really strong and solid. If I were to show you the day-by-day ridginess on this chart, it wouldn't really be there. There would be a lot of little systems going across Canada on a regular basis. So summer is going to be wetter biased once again, especially in southern parts of the region. Now, that doesn't mean we're going to be back in the floods. It doesn't mean we're going to be as wet as last year. In fact, absolutely we won't be as wet as last year, but it's still going to be another wetter biased season. The fact that we've got weak ridginess around will hopefully give us a little warmth so we can dry up between the events, but it's not a strong ridge, and I don't know that that is going to necessarily be the case. In fact, to be real honest with you, this ridge, if it verifies on any one of these charts, it is weak enough, flat enough at the top, that our temperatures probably won't be that far above average. They might actually be a little bit cooler biased in some parts of the region. Now, if we take these 18-year cycle years and we take a look at how they ranked in previous years, that ranking is at the bottom of these charts. You can just kind of scan these charts if you want. There's too much noise in there. You really just kind of boggle your mind if you were to go through it. All the oranges and browns there would be below average precipitation. You're looking at, on the left-hand side, March. The middle is April, and the far right-hand side is May. These are precipitation percentage of normal charts. So anything that's blue up there would be wetter than normal. The oranges and browns would be drier than normal. But I'm only interested in showing you the rankings at the bottom. Now you'll see 1999, these 3 years, for those of you in the back haven't even read this, the 3 18-year cycle years are 1999, 1981, and 1963. Now, what you need to know, 1999, when you're looking down here at the bottom on these rankings, don't give it a whole lot of attention because 1999 was a significant La Niña year the whole growing season, okay? We are not going to have a La Niña even in any part of our growing season, I don't believe. So comparing 1999 to 2017 is probably not a good idea, okay? So pay attention more to 1963 and 1981. The spring season precipitation in 1963 was 27th out of 68 years, and 1981 was 24th out of 68. That basically means that out of those 68 years, we're kind of middle of the road, average, okay? Nothing extreme. There wasn't anything special about them. Now, temperatures is another story. These are temperatures. Anything that's yellow and green would be warmer than normal. The blues are cooler than normal. 1981, the 4th warmest spring on history, on record, for the 68 years that Environment Canada has. But on the other side of the coin, 1963 was 29th out of 68, an average year, okay? So we can't really go too far with that, but I favor the slight warmer biases, as I've already told you, okay? Because of the fact that we've got that 18-year cycle, there's a lot of reason to support the warmer side. 4th warmest? Absolutely not. 12th, 15th, 20th warmest? Yeah, maybe. I think that's more reasonable. In the summer season, 1963 was ranked 6th wettest. That's not a good thing, especially not when you look at 1999, which I told you not to do, where it was 19th out of 68 as well. But 1981 was 29th out of 68. Again, it's an average year. Again, my bias here is that we'll be on the wet side of normal in the summer. Nothing extreme, but it's tilted in that direction. That was spring, no, that was summer. Summer temperatures, they're all slightly warmer biased, ranking anywhere from 15th to 19th relative to the 68 years. So that's kind of a good sign. I'm not convinced that it's going to be a little warmer biased, but at least it's not going to be cold summer. That's important. So the official forecast for the spring and summer is here. On the left-hand side is spring. I consider April and May to be spring. Summer is June through August, and it's on the right-hand side. Top 2 charts are temperature anomalies. The bottom 2 are precipitation anomalies. The temperatures across the prairies in the spring will be near to above average. The further north you are, the warmer the tendency will be relative to normal. Confidence is high. Okay? We will have some coolness. If you consider March part of your spring season, it'll be cool, because I think March will be fairly chilly at times, but we will warm up. The precipitation in the spring, April and May, should be near to below average across the region. Now, I've actually got some hatching in the southwestern part of the prairies, and I think I've been teetering back and forth whether it's just a little bit wetter than normal, a little bit drier than normal. Really, it probably is going to be fairly close to normal for those 2 months combined. Not a bad scenario, not perfect. We are going to have to dodge weather systems. I don't want to tell you that you're going to be able to get back in the fields and get all that old crop out, in a flash, but you will not be as wet as we have been in the past. So that is encouragement, I think, with a warmer temperature bias. Summer comes along. Our temperatures are near to above average, but mostly near normal, I would like to lean towards. There is a little cooler tendency in eastern Manitoba, and but that cooler bias is probably not great enough for us to be focused on. Focus more on the normal. All right, as far as precipitation is concerned, if you're in southern Saskatchewan, southern Alberta, a pretty good chance you'll get back into a fairly frequent rain pattern, okay? That frequent rain pattern will occur in summer. We're talking about June, July, August. As long as we get the crops in the ground in the spring without a problem, that wet bias is not going to be extreme enough to cause you much more than some concern about getting in and spraying weeds. The crop itself, I think, will have a very, very good environment to develop in. The key, of course, is getting the crop in, but I really feel pretty comfortable for the majority of folks in this room that they will get their crops in, and it'll be a fight in some places. Northeastern Saskatchewan is exceptional to this. Southern Manitoba potentially could be a problem as well because of the spring moisture issue. If we can get rid of the snow and not delay the spring access, then it'll turn out okay. But it's all about getting rid of that snow here in southern Manitoba. So the rest of the prairies will do fairly well. Maybe northern Alberta will probably have a little bit of an issue too, but there's not that much snow up there, and there's not going to be that much snow, and so that should help them get into the fields. The precipitation bias in northern portions of the production region will be near to below average, though, shown by the brown and the hatching of green and brown. So, in general, not a bad scenario, I think. What about the autumn? This is the good news. You guys beat your heads against the wall all harvest season long this year, and I am so thankful that you guys stuck in there when you could. Next year, you'll be able to take a breather. It'll be a much, much better harvest season. Okay, we won't have the excesses. By the time we get to late summer, things are going to start drying down. And when we get into the autumn season, they will be dry. And we should be able to harvest relatively quickly. So most of the pain and drain should be over, but it's going to be still a struggle in the spring for some areas. The rankings, autumn for precipitation, 1963 is ranked 9th out of 68 years, but 1981 was like 31 out of 68. Again, there's no real good strong signal there, but I tend to believe that August into September will be a drier tendency period. The temperatures in autumn will be warmer than normal. All three of those years end up fairly high ranking in the warmer bias, so that's a good thing. Okay, with that said, knowing what we're going to have to deal with here, the next question is, what's going to go on in the rest of the world that's going to impact our markets, okay? And before we even go down that road, we also have to take check of the United States because our weather can be largely influenced by what happens in the States. And it's really important for us to get a bearing. And here's the first thing you need to know. In the U.S., if there's a broad region of dry weather or dry conditions that's prevailing, and it's still there in the spring, that creates the potential for ridge building. Because if you move a ridge of high pressure over an area that's dry, the high pressure system will tend to stay there. It loves it. But if it moves over an area where it's wet, we get there, and as the high pressure system sets over the wet ground, it'll warm the soil up. And as it warms that soil up, it starts pulling moisture out of the ground through evaporation, right? Just like that pot of water, only we're warming it from the top instead of the bottom. But if you put a high-pressure system over a wet area, that moisture comes out of the soil, gets into the air as water vapor. It gets lifted underneath the high-pressure system. It gets higher enough in the sky that it starts to cool. As it cools, it condenses. As it condenses, you get cloud development, you get thunderstorms develop, and all of a sudden you got rain occurring underneath a high-pressure ridge. That is instability. That is exactly what high-pressure systems are not about. And if you put instability conditions underneath the high-pressure ridge, guess what? The high-pressure ridge collapses and goes away. You put that high-pressure ridge over a dry area where there's no moisture feedback from the soil, and it will stay dry. And that ridge will stay in place, and you'll have a significant change in weather. That's all assuming that the high-pressure system is not moving, okay? If it moves, it's a different story. So I want you to look at the U.S. dry areas. That's why we got this chart up. There is quite a bit of dryness in the U.S. in places. This was January 10th on the left-hand side, November 29th on the right-hand side. In November, we had serious drought going on in the southeastern United States. It was pretty darn serious, if you hadn't figured that out. California, big drought also. And we had dryness in U.S. Central Plains, the hard red winter wheat country. It didn't rain from September through most of December and the first week of January out there. But that's not usually a real wet period anyway. But still, all this dryness was down there. So if we were to bring a high pressure, if this is the way that it's going to look in the spring, that could be a problem. But obviously on the January 10th chart, we've done a good job in whittling away some of this dryness. In the southeastern U.S., we've taken away almost 3/4 of the drought. In fact, in a minute you'll see soil moisture, and there's no sign of dryness from an agricultural perspective in the soil in the southeastern U.S. That dryness that's still on this drought monitor is because of water supply still being below average. This drought monitor takes into account agricultural levels in the soil, but also water, river and stream flows and water reservoir levels. And until those come back to normal, NOAA will continue to produce a drought in that area. And in the meantime, we've done a good job with some moisture in California, which you can see their drought is eased, but there's still a lot of area U.S. that's drier than normal. Along came this storm system last weekend in hard red winter wheat country. All this green, if you can see Kansas up there, Kansas is in the middle of the chart here, Oklahoma down here, and Texas down here. Anything that's green on this chart is 1 to 2 inches of rain. Anything that's yellow is 3 to 4 inches, and there's a tiny touch of a few brown pockets there where they got more than 4 inches of moisture. In hard red winter wheat country, 1 to 2 inches of moisture in the middle of winter is more than they ever get, okay? Here we've got 3 and 4 inches. That drought in the Central Plains has been knocked down substantially. A new drought monitor came out this morning. Unfortunately, I didn't get a chance to put it in, and you'll see if you go back and look at it online, there's been a significant relief to the central part of the U.S. Important for us in the future because of 2 reasons. Number one, if you're playing the wheat market, hoping that hard red winter wheat's going to go in the tank, you're wrong, and it's going to turn around and be a really good crop. So be careful. If it's not too late, get out. But in the meantime, this removes the potential for a big ridge in the middle of the U.S. if it stays wetter biased. And I can tell you right now, in the U.S., in the plains, in this particular part of the plains, frequent storms will occur from late winter through their entire spring season. If anything, hard red winter wheat country is going to be too wet rather than dry. Okay, here's California, and all I really want you to note, these are water reservoirs. They're indicated by the bars. The horizontal red line is where the reservoirs should be at this time of the year. And you can see that in some cases now, the blue bar, which is the actual level of the water, is above the red. And so we're actually getting some of these water reservoirs so full now that they're actually releasing water. Now you can see there's a few reservoirs that haven't gotten their act together quite yet. Winter's only half over. Their wet season continues into April. They will continue getting hammered. They're going to get more snow and rain over the next 3 to 5 days. It will continue to go up and up. California's drought will be greatly reduced, if not eliminated, by the time we get to the spring season. Strike 2 for North America, seeing a drought in the summer of 2017. Here's soil moisture today. I want you to notice California already wet in the top and subsoil, but their water supply is horrendously low still in some cases, so that's why they're still on the drought monitor as a drought. Southeastern U.S. topsoil moisture is now adequate. There will be 2 to 4 inches of new rain in that area by this time next week, in fact by Monday or Tuesday. So that area will be saturated once again. Hard red winter wheat country, you can see we've improved the topsoil moisture quite a bit, but notice subsoil moisture is still limited. It'll take a while for that wet condition to percolate down. At this time of the year, of course, the ground is partially frozen, so some of that moisture may not get into the subsoil. My point is that the U.S. is healing itself from all the droughty conditions. That will reduce the potential for a ridge of high pressure to build up in the middle of North America during the summer season if these conditions prevail, as I do believe they will. For the 90-day percent of normal, the U.S. is pretty impressive for below average precipitation in the middle of the country. But that's really not too important because much of that occurred in November and December, and now we've got January here and things are changing rather significantly. Notice the temperature bias in the U.S. is warmer than normal, just like up here in Canada. It's been incredibly warm in the whole world this past year and a half. Here's the U.S. forecast. I'm again showing you this for 2 reasons. One, to show you that there's continuous wet weather going on in the southern U.S. If you look in the lower left-hand corner, this is January through March. A lot of storminess, a lot of wet weather bias for U.S. hard red winter wheat country, the U.S. Midwest, lower and eastern Midwest, the Delta, and the southeastern states kind of gets a split personality. You get into the month of January, which is on the right-hand side here, you can see that the tendencies are a little bit different, but we're getting our way through January. Here's what you really wanted to know is the spring season. Cooler bias in the middle of the country from the western U.S. into the central parts of the Midwest. Wetter bias in most of the key U.S. crop areas for spring. The exception is the southeastern United States. Now, one thing I didn't tell you when I was showing you their dryness in the southeastern U.S., most of the serious droughts in the southeastern United States last for 2 years, okay? We've only seen part of 1 year. Now, seeing all this rain down there right now is interesting, it's exciting, we think the drought's going away, but there's a statistical reason for us to think that maybe dryness will be coming back. And indeed, the 18-year cycle is promoting below average precipitation and warmer than normal conditions this spring in the southeastern U.S. So they may start going back the other way in about another month, maybe the latter part of March, certainly April and early May. So it may not be all over down there. In the summer season, which is on the right-hand side, near to above average temperatures, but precipitation is a little bit light in the middle of the Midwest. That's because some of that dryness from the southeast works its way in a northwestward direction, and we end up with a little bit of a drier bias. But everything's mixed. There's plenty of everything going on in the U.S. If you're looking for a wall-to-wall drought in the U.S. during the growing season 2017, I don't think it'll happen. The only way it could happen is, well, there's a couple of ways it could happen, I suppose. There's a pattern I have talked to you about. It's called the Pacific decadal oscillation. It has to do with how much cold and warm water that's off the west coast of North America. And when it gets really colder than normal over there, it can help promote a ridge of high pressure in the middle of North America. And since the 18-year cycle already has a weak ridge there, if that water body off the U.S. west coast becomes colder than normal, and you can check this out on the web anytime you want and just kind of watch it, if you start seeing that water get significantly colder biased in the spring, then the odds of us turning drier in North America, in the middle of the U.S., and maybe extending into the south central parts of Canada become higher. So we want to watch that real closely. The official forecast, my stand on that right now, is that we won't get those temperatures cold enough off the coast to create that environment, but there will still be some support for ridginess in the middle of North America. Okay, I have no idea what I'm doing on time, probably way too long, 5 minutes. Okay. I wanted to just take a minute and touch on South America, since that's controlling your market prices right now. This is Argentina. And all this blue color you're seeing in the middle of Argentina is saturated soil, in fact, excessive moisture to the point where there's significant runoff, and you've probably heard there's flooding going on there. And all that blue indicates the area that has been subjected to those conditions here recently. Argentina, in late October, had a period of 10 days where it rained very heavily in this particular area down here, which is the southernmost part of their key corn and soybean producing areas. Planting delays occurred. There was a lot of talk about a smaller crop, but right after that, they went into this dry bias. The first half of December had no rain. In fact, the first 3 weeks in December, no rain in Argentina, and it became too dry. And all of a sudden, they were talking about, well, it's too dry now, and we're not going to have a crop again. So that happened, and then we got to the last week of December, and it started raining like a son of a gun, and it's been raining ever since. Argentina will have a smaller crop this year for corn and for soybeans, and probably sorghum and sunseed as well, because of their adversity. Now, one thing we have to keep in mind, that wet years are not usually as punishing to crops in general as a drought year. So, with that in mind, Argentina will come up short-handed on some of these crops. The question is, how serious will it be? I got an email this morning from Argentina. They were talking about 3 million hectares of lost crop. Now, this particular email comes from a source that I don't know, and I don't know how much I can rely on it. There's all kinds of estimates in the marketplace about losses that run from as little as 4 or 5% up to 10% of their crop. So we'll have to wait and see. There is potential that we'll see more volatility in the marketplace because of weather fundamentals in Argentina. But on the other side of the fence, in Brazil, there's no problems. There's problems. You hear it in the media all the time. Nothing serious. The only problem with dryness is in the far northeast of Brazil. 4% of the soybeans come from there. The rest of Brazil has had ideal weather, as far as I'm concerned, their entire growing season. Taking 4%, maybe losing what? Maybe 10 to 15% of that 4%, maybe because it was too dry, isn't going to have a whole lot to say against the rest of the country, which is probably looking at yields better than average. Brazil's going to have a huge crop. Don't look for South America to pull our markets into outer space. It's not going to happen. We'll probably get a little bump in the road, take advantage of that while you can. But don't look for some kind of sustainable upward movement in prices based on the weather. It's just not going to be there. Brazil's going to, once they get into their harvest, and we get a lot of that crop in, the market's going to go, oh my gosh, look at all this, where are we going to put it? Okay? Vegetative health index, the bottom two charts, it compares last year to this year. All you need to know is that Argentina is in slightly worse shape than last year, but it's not as bad as you might imagine. And in Brazil, they're in much better shape than they were last year, except in the Northeast. And I've probably eaten up my 5 minutes. All you really need to know about the rest of the world, North Africa, for you Durham wheat guys, North Africa has been limping along. La Niña doesn't do well with North Africa rainfall. So in a La Niña year, it's usually a little dry. And it has been. Morocco in particular. But La Niña's going away, and we're starting to see some rain. And I think you'll see more and more rain. And what crop is out there in Morocco and North Algeria and Tunisia will likely end up getting precipitation and supporting that crop, and they'll do fairly well. It'll be a little small because of the poor conditions early on, but it will not be a disaster. Europe. Weather in Europe, let's see, I've got, just put a bunch of these things here. Europe was over here, everything is green and blue, plenty of moisture around. It's a little dry in Spain. I don't think this is a problem in Spain yet, but we'll keep an eye on it. CIS, the former Soviet Union, Russia, Ukraine, plenty of wet. In fact, they have just tons of snow on the ground. If they're going to have a problem over there, it's because they have to wait like you do in Manitoba for that snow to melt. Very, very deep snow there, but it protected their wheat crop. So once the flooding is over, they should do well as long as they don't lose some of that crop from the flood water. Southeast Asia, palm oil is in great shape. And China, best winter wheat crop and rapeseed crop that I think they will have ever had is in the making in China. So I'll leave it at that. The bottom line is that there is not a whole lot of reason for our markets to go up based on everything I've told you. Okay, weather fundamentals are for big crops around the world still as we go into 2017. Things can change, but don't look for it to happen right away.
Thanks for listening. We'll see you at Manitoba Ag Days 2018 from January 16th to 18th.